Hi guys, we are starting our trigonometry unit. So you'll hear us say just trig lots of times for short, so you don't have to worry about spelling that word, but just a couple times today. Real quickly, I just want to tell you that trigonometry is based on right triangles, so you'll always have a right triangle, and it's seldom the right angle you'll be dealing with. You'll be dealing with one of these two acute angles. So let's write down. That is the word SOHCAHTOA, which is not really a word. It's an abbreviation we use in trig to help you remember things. So I'm not even going to try to explain that yet, but do write it down like that. And you're going to also learn about the reciprocal trig functions. There are three main ones, three reciprocal ones, so 6 in all. So here we go. For vocabulary, this is super important that you write this down, draw the picture, and you can probably get away with just copying this chart, but you will want these actual words written down first. SOHCAHTOA comes from sine, cosine, and tangent. Those are the three main trig functions. We do abbreviate them, so go ahead and get used to this, as sine is S-I-N. Yes, everyone says sin. Cosine is C-O-S. A lot of kids try to say cos. Try to say sine, cosine, and tangent. And tangent is T-A-N. Now, the other thing you may not be familiar with that you need to get used to is this symbol right here. That is a theta symbol. That's a Greek alphabet letter. It's the word theta. It's just like a variable for an angle measure, meaning an unknown angle measure. So I just want to make sure you understand that. This information right here is the most important thing for you to memorize, and it'll be quick to memorize. Your teachers probably have some cute sayings other than SOHCAHTOA that they can share with you. So you find that on the triangle. So when you're pointing to a particular angle like theta in this picture, you want to label who's opposite, who's adjacent, and who's the hypotenuse when you're sitting at theta. Opposite means opposite, across from. So they've labeled this side as opposite. Adjacent means side by side, so here's your adjacent side. And if you're wondering, you may be saying, well, wait a minute, isn't this side adjacent to theta also? It is, but it is definitely always the hypotenuse. It is the longest side. And if you're not familiar, the best way to always spot that is it's always across from the right angle. So the functions are found by finding the opposite side length over the hypotenuse for sine. Cosine, I'm just reading off your yellow list down there, is the adjacent side over the hypotenuse, and you just simply write those numbers in a fraction and you're done. And the tangent of an angle would be the opposite side over the adjacent side. Okay, here's a little bit more. I mentioned there's three main trig functions. So here's those first three we've already talked about. Cosecant, secant, and tangent are the reciprocal functions of the three main ones. So if you notice right here, that's just saying if you take sine and flip it upside down, you'll have cosecant. So let's look at that carefully. Sine is opposite over hypotenuse. Flip that upside down. Cosecant is hypotenuse over opposite. So nothing fancy going on here. You simply flip them upside down from sine, cosine, and tangent. The only real trick I have for you memorizing these is if you'll notice, those two go together, and these two go together. I don't think you're going to screw up or forget that tangent and cotangent go together. But in the case of the other two, I just teach my kids that cosecant does not go with cosine. So the cos don't go together for the first two. I don't know. I hope that makes some kind of sense. All right, let's see how easy this is. Example 1 says to find both all three, the sine, cosine, and tangent ratios for angle A and angle B in triangle ABC. So, and then it also talks about converting the ratios to decimal equivalents. We'll do that as we finish them. So let's write that we're going to find the sine of A, the cosine of A, and the tangent of A. Let's do that first. So since I can't point, I'm just going to color. When I'm sitting at A, you need to know who's opposite of A, who's adjacent to A, and who's the hypotenuse. Please spot the hypotenuse first because that'll be for both pictures, or excuse me, for both angles. C is the hypotenuse, and there's our first problem. We do not have a value for C. So we need to take a break from trig and go do something we know, the Pythagorean theorem, and find that value of C so that we have it. That'll be 3 squared plus 4 squared equals C squared. I'm not going to show all the math. That would be 9 plus 16. 25 equals C squared. C equals 5. So I'm going to put that on our picture. And now we are ready to roll. Let's go back to our trig functions. Please look at your vocabulary list. It should be right above your example 1, and I'll just quickly write them out. Sine is opposite over hypotenuse. 5 is the hypotenuse, and I'm not going to write it on here, but this is the opposite side, and the reason I'm not writing it is because we're going to turn around and do angle B also. But A equals 4, that's the side opposite of angle A. B equals 3 is the side adjacent to angle A. So opposite of angle A is the 4, hypotenuse is 5. There you go. You just did the sine of A, 4/5. It also said convert the ratio to decimals, so pick up your calculator, punch in 4 divided by 5. You should get 0.8, 8/10. So that's converting it to a decimal. So no hard math here. Cosine. Cosine of A is A over H. The adjacent side to angle A right here is the 3. And again, the reason 5 is not adjacent because 5 is definitely the hypotenuse. 3 is adjacent, 5 is the hypotenuse, 3/5. You're done. Punch it into your calculator. Decimal version, 0.6, 6/10. Tangent of A, I'm not going to squeeze all that together, is O over A. Opposite side is 4, adjacent side is 3. When you're sitting at angle A, as a decimal, punch it in your calculator. There you go. You just found the sine, cosine, and tangent of angle A. Not hard at all. Let's move to angle B. Sine of angle B is O over H when we're sitting at angle B. O this time is this side. That's opposite. It's across from angle B. So that is 3. Hypotenuse is still 5. 3/5. We're done. As a decimal, 0.6. Cosine of angle B, A over H. The adjacent side to angle B would be the 4. The hypotenuse is 5. 4/5. 0.8. Those numbers should look familiar from where we did sine angle A over there. We'll talk about that a little later. Tangent of angle B is O over A. Opposite when I'm sitting at B would be this 3 over here. Adjacent would be the 4. 3/4. Probably don't even need a calculator for that one. 0.75. Now, most times you will be getting your trig functions off of a picture, off of a diagram like we just did, but sometimes you simply punch it into the calculator. So on the graphing calculators, you will need to go to mode. Your teachers will make sure you know how to do this when you have one in your hands. You go to mode and you need to go to this line right here, the typical preset function or preset setting is to be in radians. That is not something you know about yet. You will want to arrow over and highlight degrees. If you're not in degrees, you'll be spitting out the wrong decimal answers. On the smaller TI-30 calculators, the ones a lot of us have in our room, I think they're TI-30Xs, there is simply a button at the top that says DRG. And they are in a standard mode of degree, but you do want to check that before you start doing your trig. When you type things in, here's just an example. So pick up any kind of calculator you've got, even your phone will have the trig functions on it, and just try a couple. Type in sine of 25 degrees. You don't have to put any kind of degree symbol, just sine of 25. As long as your calculator's in degrees, it should spit out a long decimal in this case. And for trig functions, you typically round to 4 places. So make sure you can get that on a calculator. Also try this one just to make sure you know what's going on. Try typing in the tangent of 70. If I did it right, I believe it's 2.7475. So we will also use our calculators. Okay, let's check out example 2. In this triangle below, set up the 3 trig functions, sine, cosine, and tangent, for the given angle. And we're going to assume that means, and we do assume, this angle right here. That's the only one they gave us because remember we're not typically dealing with the right angle. So let's find the sine of A, the cosine of A, and the tangent of angle A. I'll write them out quickly again from SOHCAHTOA. Hopefully you've memorized it by now even. And we simply fill in the positions. It might be smart, since we're only dealing with angle A, I'm going to write opposite and adjacent on these. Find your hypotenuse first. Always across from the right angle. Opposite of angle A is this side in this particular problem, and adjacent right beside of angle A would be this one. Okay, that makes it quick. Sine of A is opposite over hypotenuse. That is 8/10. Decimal version, use your calculator, 0.8. Adjacent over hypotenuse is 6/10. Decimal version, right there. O over A is 8/6. Decimal version, 1.3 repeating. Those actually look really familiar from the problem we just did. Now, the rest of the directions say, compare these ratios to the trig functions using your calculator. So pretending we didn't know the 6, 8, and 10, let's look at the angle measure given us, 53.1 degrees. So pick up your calculator and type in the sine of 53.1 degrees. It should spit out this. And you may go, well, I had 0.8, but look how close together those are. And that's the whole idea, is if we're going from a diagram, we'll be getting slightly different answers in those long decimal versions. Cosine of 53 degrees, 53.1 degrees, should spit out this. Again, rounding to 4 places. That's super close to 0.6 exactly. And tangent on the calculator of 53.1 degrees, I got 1.3319. So this was a 1.3 repeating. On the calculator's 1.3319, super close. And this is everyone's favorite trig joke, hippopotenuse. Example 3. This time flip back the page to your vocabulary notes because they're going to want us to find the cosecant, secant, and cotangent. So just check your notes. Cosecant was the flip of sine. So when you find the cosecant of angle A, instead of O over H, you should be doing H over O. Secant, check your notes, H over A. Cotangent, instead of O over A over O. All right, let's find everything we need. If we're sitting at angle A, hypotenuse, once again, is always across from C, and there we go again, got to find that ourselves. So I'm going to quickly go to the side. If we do A squared plus B squared equals C squared, do your math there. I'll show you my total. I got that C is approximately 6.97. Since they didn't tell us to round or not, I'm just going to use that. 6.97 for that hypotenuse length. Opposite of angle A is right there. I just wrote on my numbers. And adjacent to angle A, right beside of angle A, but not the hypotenuse, is the 4. So here we go. Let's fill them in. Hypotenuse is 6.97 over opposite, and that was 5.71. Divide that in your calculator. So here is the trig function ratio version, fraction version, and here is the calculator answer. I don't mean type in sine or cosine to anything. Actually type in this division, 6.97 divided by 5.71. All right, here we go. Secant is H over A. Hypotenuse is 6.97 over the adjacent side, which is 4. That's a 7. Divide that in your calculator. Should round to that. And cotangent A over O, the adjacent side is 4, the opposite side is 5.71. Into your calculator as division. Should round to that 4-place decimal. And you have just found the 3 reciprocal functions. Example 4, we get to draw it all ourselves and then find everything. So we need to draw a right triangle with right angle at C. Most of us like to think of A as the shortest side, so maybe put your angle A over here and angle B here. That would not really matter. It can be interchangeable. And it has a side length of little a equals 4. That's your indication that you should put angle A across from your little a. Side length, small, lowercase letters, angle descriptions in uppercase letters. And a hypotenuse of 8. So that definitely has to go right here. So they didn't give us all 3 sides. So we know already that's going to be the first thing we have to do. And then it asks us to find sine, cosine, and tangent for angle A, and then turn around and also do all 3 trig functions for angle B. So lots to do here. Let's see how quickly we can go. We have to start by first finding this third side. Let's set up the Pythagorean theorem. This one's a little different from the previous ones we've had today because it's not the hypotenuse that's missing. So make sure you put a variable in one of these spots. So if you go 16 plus b squared equals 64, you're going to do some subtraction to work on this one. B squared should give you 48. Square root that, and b is approximately 6.9. So I'm going to put that side length in, 6.9. Let's go find sine of A, cosine of A, tangent of A. You try to fill them in, O over H, A over H, O over A, and let's see if we have the same thing. I hope you paused and tried to do it yourself. There's my 3 answers. Now let's go do angle B. Sine of angle B, cosine of angle B, tangent of angle B. Check your ratios, SOHCAHTOA, fill them in correctly, pause it, do that, and compare it with mine. There's my filled in answers for sine, cosine, and tangent of angle B. Please make sure you do give the ratio, the fraction version, and then also divide that in your calculator and give the decimal versions. Okay, Trig should probably be completely new to everyone, but if you can learn SOHCAHTOA and then work your way around the triangle, it's very easy to catch on to. Good luck. Make sure you come in for extra help, and there's tons of resources on Google and YouTube to help you with the trig functions. Have a great day.